which seems to be good. And let's see for YouTube if that is live indeed. And yeah, that looks live. Let me just confirm my voice. So yeah, let's get started with. So we have a lot of days which are pending. Uh, let's see if we can solve today's one. How hard it could be. As the report into Santa Alvania's the historians begin to panic. Someone from their search party is missing. A quick life from scan by the ship's computer reveals that when the missing historian reportedly arrived in the other part of the ship, the door to that area is locked, but the computer can't open it. It can be opened by physically typing the door codes, the puzzle input on the numeric keypad on the door. The numeric keypad has four rows, the buttons 79, 456, 123, and finally an empty gap followed by 0A. Usually they are arranged like this. Unfortunately, the area outside the door is currently depressurized and nobody can go near the door. The robot needs to be sent inside. The robot has no problem navigating the ship and finds the numeric keypad, but isn't it's not designed for button pushing. It can't be told to push a specific button directly. Instead, it has a robotic arm that can be controlled remotely via a directional keypad. Okay, the directional keypad has two rows of buttons, a gap, up, activate on the first row, and left, down, right on the second row. Usually they are arranged like this. When the robot arrives at the numeric keypad, its robotic arm is pointed at the button A in the bottom right corner. After that, this directional keypad remote control must be used to maneuver the robotic arm. The up, down, left, right buttons can cause it to move its arm one button in the direction and a button causes the robot to briefly move forward, pressing the button being aimed at by the robotic arm. For example, to make the robot type 029A on the numeric keypad, one sequence of inputs in the directional keypad you could use is so okay, that was 7, 8, 9, 4, 5, 6, 1, 2, 3. Okay, so we are initially at here maybe, and if we need to do 7, then sorry 0, then 0 will be moved to the okay, so A it's in initial position. A to push the button 0, okay, and then up A, that 2 will be 1 and 2, okay. Okay, that is what is that. In total, there are 3 shortest possible sequence of button presses on this directional keyboard that could have caused the robot to type 29A. Well, there are 3 shortest possible, okay. So the starting one looks the same, but so left A, up A, left A, up A, left A, up A, then right, up, up A, up, right, down, up A. This is so complicated. Um, so from 2 we can move to 9 in different positions, I believe. And so from 2 we can move either this way, or this way. So there are 3 combinations, I believe. Is left, sorry, right, up, up, and then it could be um, left, up, activate. Oh yeah, it is up, left, and up. Oh, sorry, up, right, and up. So we go above and then right, and then okay. So it will be uh, 5. So we'll move to 2 to 5, then 5 to is it 4 or 3? 7, 8, 9, 8, 4, 5, 6. Is it 4, 5, 6 or 6, 5, 4? 4, 5, 6. So we move 2 to 5, then 5 to 6, then 6 to 9. Or we move 2 to 3, 3 to 6, then 6 to 9. So yeah, there are 3 possible ways. Unfortunately, the area containing this directional keypad remote control is currently experiencing high levels of radiation and nobody can go near it. A robot needs to be sent instead. Um, when the robot arrives at a directional keypad, its robot arm is pointed at the button A in the upper right corner. Upper right. After that, a second different directional keypad remote control is used to control this robot in the same way as the first robot, except that this one is typing on a directional keypad instead of a numeric keypad. There are multiple shortest possible sequences of directional keypad button presses that would cause the robot to tell first. What? One directional keypad that you are using, two directional keypads the robot are using, one numeric keypad on a door that robot is using. Why so complicated? Maybe this is too complicated for today. I don't want to start the day like this. Maybe not. This as well. Let's see 19. That looks short. Okay, so how many days are we left here? 9 and 10. What was 9? Why did I skip 9? Oh, disk map. Disk map is a nice format to represent the layout of files and page space on a disk. This is alternate between indicating the length of a file and the length of a free space. So a disk map like 1, 2, 3, 4 would represent one block file, two blocks of free space, a three block file, four block of free space. Oh, okay, it would alternate between a file and a free space. Okay, and that one block file, two blocks of free space. Okay, so the numbers are actually the blocks size. Okay, okay. A disk map like 9 0 would represent three 9 block files in a row with no free space between them. Oh, okay, that will be interesting. Each file on disk also has an ID number based on the order of the files as they appear before they are arranged starting with ID 0. So the disk map 1234 has three files, one block file with ID 0, a three block file with ID 1, and a five block file with ID 2, using one character for each block where digit are the file ID and dot is free space. The disk map 1 2 3 4 5 represent the individual blocks. Okay, 0. So okay, the 0 is the ID file number. Okay, file ID. Okay, two spaces, then three block file, then four block free spaces, five block file with ID 2. Okay, this was puzzle input. Okay, represent this individual file. So here two block file, three block free space, three block file, three block spaces, one block of. Okay, so this is the ID. Three block free space, three block files, one block free space, two block file, one block free space, four block file, one block free space, four block file. Okay, I got it. The amphipod would like to move five blocks one at a file blocks one at a time from the end of the disk to the leftmost free space until there are no gaps remaining between file blocks. For a disk map 1 2 3 4 5, the process looks like this. Okay, so we want to move from the end to the free space in the beginning. So here we move 2 to the first empty space, then 2 again here, again here. Okay, so we don't have to. Okay, okay. Oh, that is horrifying. So we move 9. Okay, fine. That looks um, doable. That's not hard. Final step of this file compacting process is to update the file system checksum. I build a checksum, add up the result of multiplying each of these blocks position with the file ID number it contains. The leftmost block is in the position 0. If a block contains free space, keep it instead. Okay, okay. But there won't be free. Okay. Content count. Continuing the first example, the first few blocks position multiplied by its file ID number are 0 times 0, 1 times. Okay. So we multiply the indexes with the file ID numbers. Makes sense. 3 times 9, 4 times 8, and it will be 5 times 1, 5 times, sorry, 6 times 1, 7 times 1, 8 times, sorry, 8 times 8 maybe, so and so on. In this example, the checksum of this sum is 1928. Okay. Compact the ampli port's hard drive using the process he requested. What is the resulting file system checksum? Be careful, copy pasting the input for the puzzle is it is a single very long line. The input was what? That was a number, right? Yeah, like this. So what is the input? What? This is a single number? Okay, that will be. I mean, this obviously cannot be stored as a single integer. Could it be? I don't think so. And nor we should, because the number itself doesn't uh, make sense, right? Like we don't want the number to be stored as integer. We can cast it to integer maybe on the fly, but um, yeah, we just need it while computing a checksum, so that should not be an issue, I guess. So yeah, let's get started. So let me first set it up. I'll explain the logic, maybe myself, understand what we want to do it. But first, let's pass the input. It should not be a repetitive process. So I don't want to do this, but yeah, let's want to compile this. So helpers dot read file lines. We just have a single line, so that should not be an issue. So yeah, let's just write that out. So we are running it. So this depends on where are we running this from. So inputs day 09 slash sample.txt, and so we want the number that we can just get it from the lines of 0, and we'll just print that out. So if we do go run main, sorry, so it is source day 09 main.go. Okay, we are able to run the numbers. So now I need to think about how we can approach this. So um, let's take the shorter example. This will be the one, and yeah, let's go to scaled draw. Yeah, let's see here. Let's paste this in. So now we have 1, 2, 3, 4, and 5. What uh, first thing we need to do is we need to, okay, so let's not think about what we need to do first. We need to understand what we are uh, getting in the end. So we want some representation like this. Uh, this is the first example, right? 1, 2, 3, 4, 5. Yeah. So I'll grab this thing. and paste in here. Oh, what is this? No, it's not a chart, bro. No, Control Shift. Yeah, it's a good feature actually, but not intended right now. Yeah. So initially we want. So at the end we wanted this kind of format. So uh, maybe we can create. Um, and in the end we want to multiply the numbers, and we cannot use zero. Okay, so let's represent it as a list of integers, and if there's a free space we can represent it as -1. Yeah, -1 should be good. So what we would do is first we iterate over the string. So we have the individual characters. So first we will have one, and we want to make sure we are keeping track of the indexes. So in this case we have so this is at the index 0. So I'll write below it. So these are the indexes 0, 1, 2, 3, 4, and only I guess at uh, even indexes in indices uh, we want to populate the files blocks, and at odd positions we need to populate it with -1 or free spaces. So in this case, what we would do is we will first iterate over all the uh, numbers in the string. It will be a string, obviously. We need to cast it to integers, so we'll cast into integer, and hmm, we need to append to the list of integers. So we'll first create an empty list of integers, right? Yeah, I'm thinking in Golang, but you can get the point. Just a second, I am. Yeah, so we would append one after converting it into integers. So we'll iterate over how many ranges that like how many blocks we want to append. In this case, it's just one. So we'll append 0. So we will also need the ID of it. So we'll keep a track of what the ID will be. So only at even positions we need to do it. So we'll keep a ID handy with that. And yeah, so um, and if that index is negative, we will append -1. And if it is positive, sorry, it's the index is even, then we will okay. We need to cast integer anyways. So we first cast it into integer, and how many time we need to iterate. We simply append -1 or the number itself, the ID itself, based on how many, uh, based on the index, if it's even or odd. So yeah, I've got that point. I'll explain to it a bit more in the code. And next thing we need to do is the actual moving of blocks. So what we can do is so we need to move. Um, so we stop over here. That is when none of uh, the blocks are in between empty, right? The amplified would like to move 5 blocks one at a time from the end of the disk to the leftmost free space block. Okay, leftmost free space block until there are no gaps between file blocks. Yeah. So we keep moving until we see there is a gap here. That will be quite uh, intense, right, to compute the gap between free spaces and sorry, two uh, neighboring file blocks. So we first shift two, then again two. Let's look at the bigger example. Maybe get more idea about this. So here the last gap was okay. We have to keep look at the recent one. That will be quite tricky. We can't look at over here and say this is the last gap. So we'll just stop in this case. But there are still gaps here. So maybe we need to. Okay, yeah, we can keep track of the like a what you call a placeholder over the free space block, and then continuing like from the right and from the left as well, right? Yeah. So we can do like a left pointer and a right pointer, or it's called two pointers. I don't know. So we can keep one pointer over here and point. You can call it placeholder pointer, whatever. But we'll keep one pointer at the first free, uh, the first index, zeroth index, and here at the last index, and we'll keep on moving this leftmost pointer to the right and until we see a free space. So next we move here, but we will keep over here this over here because we have not found a free space on the left. So we keep moving it and then we see a free space. We swap out the right pointer and the right left pointer. Not the pointers, but the value of the index that they are pointing to, and then move the left pointer and also move the right pointer because we have swapped the element out. And yeah, we'll keep swapping out until we see a free space here. And at one point, the pointers will like what we call overlap, or they will they will cross each other. So the at one point those two will be at the same position. In that place we can just stop, or we can just say that this is the final position. And yeah, the computation I think it's quite straightforward. You just need to multiply the indexes and the number itself. So that should not be any big issue. And if we see -1, we just quit it because there are no spaces in them. We don't count -1, so it should be good enough. Okay, so that looks pretty simple. That is part one looks simple. Let's see how we implement it in Golang. So first thing we need to do is we need to construct this list of integers that will represent this first file like, blocks by block. So we'll create a function called what will we call it? Create file blocks, and we'll take in a string which we'll be calling number as a string, and we want to return the list of integers. So what we will do is for character in range, stop at that. The number, we can do that, right? will create a list of integers which will be calling it file list, file blocks. Okay, that will be a room type, right? So we need to cast this string. I hope we can do that. And that looks good. Okay, so we can iterate over the strings. I didn't know that, but yeah. I thought we need to split the string maybe. Maybe not. Maybe we can do that, but uh, never mind. Um, okay, so now what we do? We for sure need to convert that string into an integer. So I'll call that as num, and we want to ignore that. Just click on v to convert that uh, character into integer, and also we need to keep track of the index. So sorry, strcommit.atoi, and if I mod 2 is 0, I think I saw somewhere, I read it somewhere, like there is a better mod expression because mod is a little expensive. I'll do it after we solve this. But yeah, so if it is even and if it is odd, for the odd part it is quite simple, right? We just iterate for range num. We can do something like this, right? I hope we used to do that, but yeah, for I, okay, we still need to check of that. So variable of type what is it? Integer. We just call it k. We can't do that. The recipe seems to be complaining it, but maybe it's outdated. I'm not updated that maybe. Um, what is that printing it? So it is 0, 1. I need to do that first. So we for sure need to iterate over that, and we need to do what? We need to append file blocks with okay, now we need to keep track of the ID. File ID will initialize it with 0, and at of each of the file ID I'll increment it. Okay, not at each file, just at the even when that is even position. So we'll append it to the file ID here, and I think that is it. And here we need to append not the file ID, we need to append -1. Let's check that out. We don't need this. Content folder is not used. File blocks. So let's go into the file blocks. Okay, it is something. Let's check that out. It is 0, 0, minus 1, minus 1, minus 1, minus 1, 3 minus 1s. Yeah, 1 to 3. And then 3 ones. 1, 2, 3 ones, minus 1, 3 ones, 2 is 1s. Yeah, that looks good. Maybe we can also do number as 1, 2, 3, 4. This was the example, right? So you can see 0, minus 1, minus 1, minus 1, 1, 1, 1, minus 1, minus. This will be 4 times. 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay. Oh yeah, so 4 times minus 1, 1, 2, 3, 4, and 5 times 2. So that is correct. So the first part, not the first part, but setup for the first part is done. We need to now do move file blocks. So we need to move the file blocks. We'll take in the file blocks, which will be a list of integers, and we will return a list of integers after updating them. Okay, what we will do here. So we'll start from, so we'll keep two pointers, right? Which will be, I'll call it right pointer, not right pointer, but free space and file block. These are our two free blocks. So it should be free block and file block. So we have two pointers here from 0, one from the right, one from the left, another from the right. So we'll keep doing it till the free block is less than file block. Free block is less than file block, yeah. And if we see that free block has -1, then what we do? Um, we take what is at so I think we can do in Golang this way. So file block, we want to mutate that. So with the free block and file block of okay, that has created some confusion there. That might create confusion, but never mind. So we take the file. Why this one? We basically want to swap these things out. and this. So once we swap this out, we need to move both the pointers. Um, so free block pointer will be, sorry, let's make file block plus plus, and this will be plus, oh, sorry, file block will be negative negative because we need to move back. We need to move the free block ahead. Okay, let's test this out. This won't work. First try. Okay, now here I need to pass the copy of file blocks because that will mess up that. So file blocks one, file blocks moved will be move file blocks slices dot clone the file blocks moved. Did we do anything? Oh, sorry. Uh, if the file blocks at free block, if that is negative, then only we do that. Yeah. So what is this code? So this is wait, what number is here? Okay, this is original function. So let me check that quickly. So it was 0099 triple one triple eight two. Oh, it is still -7 here. Why? So let me print out this at the every iteration. Okay. So we first swap negative 9. Sorry, 9 with -1. Then this. But if you see this one, oh, we also need to take care of it. That is not negative. Okay, that's very interesting. L if file blocks of oh 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 let's do and here. If the file block is not negative, right? Else if file blocks at file block is -1, then you basically do this, correct? That looks correct. 0 double 9 8 triple 1 triple 8 2 triple 7 8 triple, yeah, triple 3 6 double 4 6 triple 4 times 5 Double six. Yeah, that looks good. So that is done. We can remove this logging out. I think this is it for the part one. Let me grab the input. So input prod. Did I copy it correctly? That looks short to me. Okay, now it's so. Oh, we are not completed it yet. I'm so excited, but yeah, we have to do the checksum. Calculate checksum. So we'll take in the 5 blocks, which will be a list of integers and return a single integer. So for we just need we also need the index. So this will be the number and ranging over the 5 blocks. So we treat the checksum as 0 initially, then we need to increment it with the number times I. If num is equal to -1, we simply break and return checksum. One nine two eight was the expected output for that sample. What was it? 1928. 1928. Oh yeah, that looks good. Prod of txt. It is 1009941. How? How is that wrong? Oh, this looks messed up. No, that is not a expression. Let's not print that. Let's actually print. It's too much. Let's not even do that. And now my screen is stuck. What is wrong here? So we are keeping on it until we see this. This doesn't look wrong, does it? Then if we are trying to do this, we are moving three block. Um, Maybe that is the issue. Yeah, let's handle that case separately. So else, which means here the file blocks is negative. Sorry, it's not negative one, and that is also a block. Hmm. We need to continue here because that is found. No, no need to continue. Okay, log is less than file log. Oh. This should not be negative one. Uh, do I add and continue here? Doesn't matter. This is for uh, yeah, that is correct. So let's keep this in and run this one. Got in. So what would be the part two now? Part two, upon completion, two things immediately became clear. First, the disk definitely has a lot more continuous free space, just like the MP pod hoped. Second, the computer is running much more slowly. Yeah, more maybe introducing all of that file system fragmentation was a bad idea. But individual blocks, he'd like to rather than move individual blocks, he'd like to try compacting the files on his disk by moving whole files instead. Oh, okay. This time attempt to move whole files to the leftmost span of free space blocks that would fit the file. Oh, attempt to move each file exactly once in order of decreasing file ID number, starting with the file with the highest file ID number. If there is no span of free space to the left of a file that is large enough to fit the file does not move. The first example from now proceeds differently. So we first have we start from here itself. So 9 it is a two block file. So we move here. Then it is four block of eight file. So one, two, three. Okay, so there is no free space for eight block of files. So we keep it as it is. Okay. Then we have three block of seven, which can be fitted yeah here because it's already occupied by nine. Then yeah. Then we have something like this. Then we have six block of four. Okay, four is not available. Five is also four block, so that is not available. Four is two blocks, so we can fit it over here. Four here, okay. Then what happened? Why is this two removed? Oh, okay, that is a little. Okay, so we keep moving the files until we see. Oh, okay, that will be quite interesting. Okay, the process of updating the file system checksum is the same. Now, this example is someone need to wait, right? So we don't count the negatives, and that would be good. So yeah, we continue if there is negative one, but yeah, that is the simple thing. Mm, so how do we approach the second day? Well, that could be simple, right? Like we just need to do it like continuously, but yeah, that could be doable. Let's see how we can do this. So first I'll clean up this part. It will be part one. And yeah, let us define a function that will move um, five blocks. That's not a good name, but who cares? We want to return a list of integers, and what we do here, so the current, what we do is we need to iterate over the files from the end. Then what we could do is we could check if the file blocks at that index is not it is equal to negative. No, it should be not equal to negative one. That is, we have something over there. So if that is the case, then we basically want to count this like a length of that file block, right? we can have that, but that will be a little complicated thing. Like we can create a sort of map, right? Like a map of what is the index of that position, that file and where it ends. So a map of integer with integer, but I'm not sure that will be a quite good solution because we need to compute it after every swap. That will be quite expensive. So what we would keep track is, let's say, the file, sorry, the block size will initialize to 0, and here will what we do, we say that the block size is plus plus, and we need to check if the previous file is not equal to I mean it should be not equal to that, the current one, and if it is that, then uh, so if that is the case, then if we now need to move uh, that block of file to the free space available on the left side. We also need to compute that size as well. So instead of here we will reset the size, but let me call create one more function because that will be handy here. This will be move free space, or not move, swap free blocks. It will take in what the whole file blocks file blocks with our integer, and we need to pass in what uh, need to pass in the the start and the length, or I should say the size, and will return a list of integers maybe. Or okay, we can do that, but we will mutate that variable maybe. So now we need to iterate from the start. So let's do it here. So for I is 0, I is less than so this should be before the start, right? I plus plus, and if we see that uh, the file blocks at I is equal to -1, and oh, we also need the previous one. So we'll start from 1 and we'll compare the previous one is that equal to minus 1. And if maybe let's not do it here. Wait, which means this should be minus 1 and this should not be minus 1. Wait, hold on. I am doing this. So we also need to compute the free size. Yeah, or I should say block size. And if that is the case, then I need to implement it. Okay. So we also need to check if the previous one was -1 and the current one is not -1, right? In that case, we sure that uh, on the free space count is less than that. So the block size will be less than the size, or it should be greater than, because we need to swap only that elements which are swap the uh, file blocks which are contiguous for the free space. So if that is the case, then uh, we need to iterate over all the length, like all the file blocks, and till that point we need to swap on the elements out. So for okay, this is a little tricky. Then fine. Okay. So for so we need to subtract the index where we started off with the with the block size, and keep swapping the elements from the file block to the free block. Correct. So here we know that this block size is 2, and here file blocks, the current one is not, so okay, let me confuse something. So if 5 blocks by minus 1 is -1, which is not here, and we'll keep on incrementing it till we are over here, then we see that block size is 1, then we move here, and okay, actually this should be not -1, that is, we reach over here and the block size will be 3 at this point, and what we need to do is block size is less than the size, so we basically need to compute the difference of this indexes to the block size of this. So for file size will be we can call it swap size will be block size minus size, and if for so it will be start index block size minus size. No, it will be um, I minus. So once we have found the starting index, we need to iterate till so we can start from start index and till we'll keep on incrementing till we have got the size of that correctly, and then we need to swap this out. So blocks size is not defined. So we'll use k here because I is already used. And once we are here, we need to 5 blocks of k. This is the current index, and we want to take this we take the start +1. Mm. Let's keep track of index because this will be offsetted by the from the actual length of that string. So we need to keep that start index by index, and we'll swap this out with this. Okay, so once we have swapped this out, um, we also need to reset. Oh, no, we cannot reset here. So we'll call this function here swap of 3 blocks that will take in the 5 blocks. The start index, which will be um, the I minus block size, and the block size. Return the 5 blocks. So let's take shorter examples, something like txt. That is also quite big. Let's take 1, 2, 3, 4, 5. And so what happens if this is negative 1. So if that was not negative 1, then which means the 5 blocks of I is not, it is negative 1. So uh, we can't do anything over here. So we'll call this 5 blocks swapped, which will be uh, so block size and the I minus block size. Will compute on that. So 139. Um, let's not print this. Let's print that. And we first need to print the 5 blocks at I. So it is 9, 8 is 7, 9. Um, so there are 41 characters or 41 blocks. And the first, what is 1? Block size 1. Okay, 9. It is not 1. Okay. So block size should have been 2, right? So we go from -1, then we go till -1, then it should not be 1. So we only encountered this once when we stopped that. We go from there to 1. So if 5 blocks is not equal to that, so what is the 5 blocks? I minus 1 in this case. It is 8. 5 plus 1. Oh, it should be plus 1. Yeah. Should it be plus 1 or. Yeah, now it is 9 and 9, 37. So 13. It should be 40, 39. How is it 37? I minus block size. So block size is 2. We don't need to move this. Yes, we just pass in I. Now maybe I minus 1. So we are at 39 and then we should swap it out. So let's see what happens after this. So block size. So here I didn't swap that out. Uh, so 3 and 2. 0, 1, 2, 3. And okay, so 3 size and 2. Okay, that is correct. So we should have swapped out here, right? Mm, maybe not. So so here it says it is 2 and 2. Okay, start index is 2. Size is okay. Start index plus size. Now that should have replaced that. Okay, -1 and 8. So 2, 2 and 38 is, the start is 38, which means, okay, okay. So we are missing something over here maybe. So if till what time we do this, find it be -1, then increment the counter and stop. and it swapped it out into block 1. So this one will be block 3 and 8. What are we doing now there? So block size is 3 and start index is 8. Um, so block size is 3. So this condition is correct, right? This is equal or it should not be -1. If the block size is greater than that size of the 5 block, then we uh, swap that out. Wait, why do I have this? So we swap out three uh, three elements with the ID, which means we are not updating the index, right? So index will be 0 and index is incremented every time. So we are looping through this. So we pass in the start, which should be like the index of the current file, right? Like that we are setting it from here. It is current block size. Oh, this is issue. So we start at I plus 1. That will be, should be I. No, should be I plus 1. Why we are off by 1 here? I believe that we are off by 1. No, we are. I is equal to -1. Why is this negative one though? Like this should have been one. Block size is showing as one here. It is not right. But here in this case it is showing as 3 for where is that block size. But here this block size is reflecting as 1. As you can see here 1 is 9 and I is 40. So I is 40, which means it has picked up the uh, last index and it has not gone through that. So which means either these two are wrong or we are doing something wrong here. So what is the first condition? If it is not negative 1, then we increment the size. So let's print this here as well to indicate that we have indeed came here twice. So we should iterate over this twice if it is 2, 2 comes 1 here. So 5 block size at I is not negative 1 and it is not negative 1. So why is that not printing out here? Mine wrong, like wrong space. Okay, size 1. Uh, oh, that size 1 and size 2, but uh, we are off that index. You can see that. Okay, that is fine. So back block size is 2. We are swapping the ninth one and the 40 is the should that be 40? If that is not equal to this, then so we increment 1 here, and if that doesn't equal to the previous one, then we come over here, so it should be 1. Yeah, it will be 1 because it should have been 2. Now I'm confused. Maybe we can do a little hack here. Oh wait, we are printing n correctly. Okay, that should this will be better. So you see now it is 40 and the original index is 42. So we are at 40 and we are swapping out negative 1 and with 9 and negative order with 9. So why do we enter this space again? Like uh, we would have where we enter this position, we set the block size is greater than size, and we swap this out, and we again set the block size to 0, and so start index is now negative 1. We should not technically enter this condition. So here, why do I keep? So here at this point, block size was 3 and 2 was this one, and after you swap this thing, this is 3, this is still 2. Why is that? Because here we set it the block size. Oh, is it because of this? So here what are we doing is file blocks is -1. We want to do that because if it is -1, then the block size is better than 0. We don't want to do this, right? It still does that. There is some issue with this only, I believe. So we start from 1 and we end at original index. So we will start. So that will be the position where you want to swap that out. Original index. And then if we check here that this should be a contiguous block. That is, if we have broken that contiguous free block, then we check if that size was allocated was indeed greater than the or yeah, greater than the size of that. And if that is the case, then we would like to swap this out, right? And if the file box was -1, then we include the block and the start index was -1, then we assign the start index as I. But why are we not breaking out of this? Let's write one function called swap block. So in this case, what we will do is we will just pass in the file blocks and the file ID and what else we can pass in the size and also the start. Let's call it index. So we'll iterate over the size and we'll say index plus I will be file ID, right? Yeah, that should be it. And instead of doing this jargon, just shit your jargon, we can just say um, actually this would be the issue. We can say what is it? Swap block with the file blocks. I need to pass the file ID first. So in that case, it will be what? Uh, how is file blocks that I then the start index will be the start index, and we pass in the block size or size. Actually, not this. I got where the issue was. Yeah, this should be to this. Yeah. Oh my god, that took a while. So now if you see 09 to 117, negative 144, negative 133, negative 155, that looks correct to me. Now we just need to pass the checksum of this. That will be part 2 will be calculate checksum of 5 blocks swapped. Part 2, and hopefully I can once helpful, now annoying print statements. Okay, 2, 8, 5, 8. Yeah, I know this. Instead of break, we can continue because there could be chances of that. And yeah, 285, that is correct. Now I'm not sure why I am doing that. Okay, let's hit that. That took a while. Never mind. What is 9.972? What is that? Like, yes. So day 9 is done. We are at day 10 now. Should we do this? That looks easy, does it? Topographic map. Yeah, I think let's start with day 10. So you all arrive at a lava production facility on a floating island in the sky. As they begin to search the massive industrial complex, you feel a small movement. Okay. The reindeer is holding a book trail lava island hiking guide. However, when you open it, discover the most of its rooms have been scorched by lava. You are about to ask how you can help. The reindeer brings you a blank topographic map of surrounding area. Your puzzle input. You look up at you and looks up at you excitedly. Perhaps you can fill in the missing hiking trails. The topographic map indicates the height at each position using a scale from 0 to 9 highest, for example. Okay, based on the unspots graphs of the book, you determine that a good hiking trail is as long as possible and has even gradual uphill slope. For all practical purposes, this means that a hiking trail is any path that starts at height 0 and ends at height 9. Now, you can just by height of exactly 1 at each step. Hiking trails never include diagonal steps, only up, down, left, and right. Okay, you look up from the map and notice that the reindeer has helpfully begun to construct a small pile of fences marked by rulers, compass, stickers, and other. Okay. A trail at any position that starts one or more hiking trails. Here, okay. Will have a height 0, assembling more fragments of bridges. The example is single trailer in the top left corner because it can reach a single 9 in the bottom left. So we start from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, you mean like we can reach like the how many unique sets there are, right? The unique maps of, I would say, positions, not values, because values are the same because 0 and 9 will be the same, but we need distinct sets of, I would say, position because we can reach, so in this case, we can reach 9 in different ways, but we start from the same 0 and end at the same 9. So if there was one more 9 here, then that score could have been 2 for the trial head. Okay, so bottom you can see here it has trial had a score of 2. Okay, yeah, we need to kind of create a map of positions. So we will also okay, map. Okay, this trial had a score of 4. Okay, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so 9, 9, 9, and 1, 2, 3, 4. Oh, okay. This cannot be reached because yeah, there is zero next to it, so there's no clear-cut example there. This topographic map contains two trailheads. The trailheads of top two has one. Okay, it has 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so via 0 at the bottom we can reach two nines, and via this 0 we can reach, this won't count it, right? Because 6, 7, 6 is not, uh, the trial at the top has a score of 1. Yeah, okay. The trial at the bottom has a score of 2. Yeah, this 0 can be reached from two positions, 6, 7, 8, and 9. Let us 2. Here's a larger example. This large example of has 9 trailheads. Considering the trailheads in reading order, they have scores of 5, 6, 5, 3, 1, 3, 5, 3, and 5. Okay, that's not that hard. Like we can do it. We just need to start from 0 and find all possible positions that lead to distinct nines, I believe. That is similar. That is not hard. Let's see. Okay, so let's start doing it. We can just do a 10 here. So we need to construct the grid. I think I have a helper function. I'll need to go through that. It was in the 4, I believe. Yeah, directions. I'll use that as well. I'll copy it to where is the helpers. So need to import strings. So I'll also maybe create. Okay, so that we have the input. Now, what we need to do is, okay, let's think. Uh, we need to find trailheads, right? We need to, let's open this up. So we need to find, so we can iterate over all the rows and we can say that if the we find 0, then what we do is we need to mm, move in all sorts of directions. If like it would be, we can move diagonal. No, we can't move diagonal, right? We cannot move only. We can only move right, left, up and down, I believe. Yeah, that is correct. We can only move up, down, left, and right. It will never include diagonal steps. Yeah, up, down, left, all right. So then, if we once we have found zero, we can move to right and see there is one, and then we can see uh, if there is two in the right, no, two in the down, yeah. Then we move to if there is three in the right, no, down, yes. Four in like uh, right, down, left, yes. And we see it is there. And for six, we see left. Five, we see right, down, left. It is there in the left. For six, we see right, there is no seven. Down, there is no seven. Right, there is no seven. Sorry, left, there is no seven. There is up in seven, there is up. There is seven in the up direction. Now we see that there are two eights here. We see that eight is here and here. Okay, how do we fall back there? Okay, maybe we need a condition there. If there is no in like so in the first case we saw two was here. We cannot move backwards. Again, so three was here, but we have uh, not checked this direction here, and we also not checked this direction here. We have moved downwards. We have not moved right, so we need to consider that as well. That is the case. Once we have found 8 here and we move 9, so this was the trial path for the first case, right? So we mapped 1, sorry, 0 with 9. It is the positions of both of them. And so that will be the, like, for this trial, there will be one score added. You can find multiple positions of this, and that should be your approach, I believe. So let's get started with it. So first we need to do is uh, find heads, find start. So we'll take in the middle, which will be a list of integers. Sorry, a list of integers, and we want to return a single integer score. Then we call it the score will be zero. Then for this position I messed up last time, so let me do this way. So we are iterating over all the rows, and for each row we will have that num in the range, which will be the row, and if the number is equal to 0, we have found the trial at start. We don't know if that is a actual uh, thing or not, but yeah. And here, so we add up all of them, right? Here scores of 5, 6, Mm. Now we need to write one more function because we need to do quite a lot of things, which will be to what we'll name this. We need to move the trailer, so call it find trailhead score, and we need to take in the grid obviously. We need to take in the so where are we starting? So this is the start index, and this will be okay. I also learned from another mistake, which will be to create a structure for position coordinates. So I'll call it point. Type this will be x will be int, y will be int, and start will be a position point. And do we need any other thing? Hmm, maybe not. And we need to return what? So we can return a map here of so we want to return so we will take in the point. That should be a point, right? And we can call it boolean. Maybe maybe let's call it integer. We can keep track of how many points we have reached there. So that is that. And what do we do here? So I think we do something like x next and y next. For that, I'll create a separate function which will be move with move. Yeah, let's call it move. We'll take in the grid and we'll position like the start point and we'll return. I know what it will return, but yeah, we need to find the valid positions, like how much, sorry, not where all we can move. So which are the valid steps here? Like valid trailheads, we can not trailheads, but uh, valid. What is it? Positions, yeah, positions or whatever it is called. So we need to first we can check all the directions for direction in helpers dot directions. I'll just grab the first four because I think yeah we can go up. Right will be plus, left will be negative. Yeah, So I will go with the first four directions, and what we will do is we will keep track of all the positions which are valid positions we can move on. And if the start of x is greater than 0 and the grid at start.x, so what we can do is, since we are storing an integer, uh, we can just check if the start is, like, mm, mm, okay. How do we do this? If the like y next, sorry, this will be so we first need to make sure that we are the current x is essentially correct. Just start at x is greater than 0 and the value is so how do we do this? That will be grid that x next, sorry, y next and x next is plus 1 because that value will be indeed safe values, so we can just say positions equals append uh, need to append the point, so this will be x will be x next and y will be y next. Sure, once we have all the possible positions, so we can return this. This will be a list of points and will return positions. Oh, yum, you are now messed up. Come on. So what we need to do here is so the grid at start x, the start y, and start x is 9. You need to do that thing, right? If that is okay, we uh, now we need to construct a map here. Find trailhead score. We will call it from here. So let me create a map of trailheads. Will be make a map of cycles of point with integers and trailheads of the start is if that is not found we need to append it or we need to add it, so this will be plus 1 here and we return the trailheads else. Okay, now is the actual thing, so we'll get all the positions here, so uh, let's call it positions and we'll what was it called, we move on the star no we pass the grid first and then the start if the so if there are no positions found, so which means this is 0, then we need to return pallets and yeah that is pallets, else we need to run through them again as well, right? So we'll range through this the position and range positions We need to update the trial with trial score. We'll take in the grid and what did we pass in here? It is a start. So we'll pass in the position. This is the next position that we need to visit. And yeah, I guess that's it. The grid. Mm, oh, okay. Yes. Oh, I did what? I think I'm not having this one. This should be within the ranges. So uh, start of the grid minus one. We'll do the same for x. Yeah, let's do this one. This is okay. So what I was trying to say was that 0 and 2. So 0 and 2. We first found this index and then we are going here and we say that this is not 9. This won't run. So we move and we find all the possible directions. So here we are not printing out that even. Why is that a thing? Maybe, okay, let me print it here. Okay, so we are finding that is here. Start of x is greater than 0. this is wrong actually. It should be greater than equal to 0 because y and x will be 0 as well. So if it is that right, no, okay. So at least we are moving in the wrong direction. This could be true. Let me print out the direction at least. Direction vertex, no, sorry, y and direction of x. Direction is -1 and 0, which is down, or up, that is up. Okay, so we cannot go in the up direction. And if we try to add y to this y next, the first condition is will be good enough, but this won't be the case in this case. Okay, so we are missing one condition for sure. And what is that condition? X next is greater than 0 and y next should be greater than 0 as well. This is 0, that is fine. So now we found 0 and 1. We have found two possible cases here, 0 and 1. Then 0 and 9 is not a valid way to get that, right? So the move and my bad. Oh, that is correct, right? My next stop. Next. That is wrong. That is wrong. This should have been. So we need to say that the start of y and the start of x is this. No? Yes. Yes. So here on the top we have found 0, 1 and 2 and 1, 3 and 0. So in the left position, so this will be left, right? No, this will be up. So up is not valid. 1 0 is down. So we found one here. We will append that to the position. So it will be interesting. Let me run this. So position is this, and now it becomes 2 comma 1, which is 2 and 1, which is y is 2, x is 1. Or x is 1 and y is. So if you go by that round, that will be indeed correct. So this will be the position, and then we add in 3 comma 0. That is 3 comma 0. Okay, this one makes sense. Then we go to down with one of the directions, that is 1, 1 and 0. That is not what we expected. We need 1 and 2. So here we need to add 3 comma 1. So we found y, yeah, 3 comma 1, and then we need to find 2 and 3. So we found it here, which will be in 3 comma 2. Yeah, that is correct. Then we found 3 comma 4 and 3 comma 3. Yeah. Then we found 5 with 4 at 2 comma 3. It is at 2 comma 3. Yeah. Now we have two possible combinations. That is working fine. Where is the issue now? So index out of range 8 with length 8. Where are we accessing distance? So this condition should be suffice, right? This should be greater than or equal to 0, and this should be less than the. Still that. So we know for sure that 0, 1, 2, 3, 4, 5, 6, 7. We are accessing the seventh element, and that is causing an issue. So if y is greater than 0, and it is possibly in the y next thing, len of grid. Now we have guard clauses that won't allow this to be accessed. Are we printing it somewhere? Oh, here? No, that is not correct. Hmm. JNI. So we see 3 comma 4. where are we seeing 3, 4? There are multiple places. Let's see 7 and 0, which means 7 comma 0. This should be the one, and that is not correct. So, okay, that could be here now. So this should be greater than or equal to 0. Let's print out. Okay, so we are accessing this 8th element here, which is x next. Oh, okay. Yeah, now it is correct. We can stop yelling at this. And now we need to see if what are we printing here. Okay, so we have printed 1, 2, 3. Okay, maybe we need to pass it here. X will be a map of replace word point with integers. Trial hex, and we'll just pass one here. We need to pass it right here. For each, this will be unique, right? 36. Oh yeah, yeah. That is the answer. Now let's grab that. 733. That looks small, but the input is also not big. Yes. The reindeers kinds of familiar to paper describes the second way to measure waiting time. Everything is fine. Okay, wait. Hold on. What do we need to do? Do we just find the rating of 13? Okay. We need to keep track of the counts that we find here. Okay. Hmm. Can we do something here? So what was the previous one? I didn't get it. Like what? Distinct trailing trails with the that trailhead. So zero is a trailhead here, the single trailhead. So it has a single trailhead. Why? Because zero. Oh, okay. Got him. So you are saying that this one has one. Maybe just I don't know what I'm doing, but let me think if that is the correct answer. So we can just print here line of the trailheads. Okay, no, okay. What are we doing here? Because there is a 3D writing trip will be great. So you are saying that if we find start, we just implementing that one. That is weird. We'll see you next.